Okay, so we just finished up the first page of the test review. Now we're going to do the second page of the Unit 4 test review, starting off with the solving problem. So when we're solving equations, our number one goal with radicals is to isolate the square root. So get the square root all by itself. Once you get the square root all by itself, you want to get rid of the square root. So the only way to get rid of the square root is to square. And if you square one side, you have to square the other side. So whatever's on the other side, you got to square that too. That's like, in a nutshell, that's all that you need to do for these problems. That's it. Just, get the square root by itself and square both sides. Then afterwards, after you get your solutions, you want to check for extraneous solutions. What that means is that you want to plug your number back in, because sometimes you're going to get a number that doesn't actually work for the problem. And you need to plug it back in to verify that it actually works. All right, so let's start on number 17. So number 17, I need to get the square root all by itself, so I'm just going to circle the square root. Now, this says -7 times the square root of v is equal to -28. So to get rid of that -7 times something, I need to divide by it. So divide by -7 on both sides, and you get the square root of v is equal to 4. Now that you have the square root all by itself, you square both sides. So I square this side and I square this side. The nice thing is that the square and the square root just cancel out, so you just have v, and then 4 squared is 16. So there's your answer, v equals 16. But remember to check for extraneous solutions. So what you want to do for that is take your original expression and plug in 16 for v. Excuse me. So we get -7 times the square root of 16. And we have to see if that's equal to -28. So we have -7 times the square root of 16 is 4, and the -7 times 4 is -28. So since these two values are equal, then this checks out, and it's not an extraneous solution. So we're going to go through the next couple pretty quickly because it's almost identical. And then when we get to 21 and 22, it's a little bit different, but still not that difficult. So the square roots are already all by themselves. There's no adding, there's no multiplying outside the square roots, so all we need to do is just square both sides. So we square both sides, that just gets rid of the square roots, and we have 2m minus 4 is equal to m, and then just start solving. So subtract m from both sides, you get m minus 4 equals 0. Add 4 to both sides, you get m is equal to 4. So there's our solution. Now we go back and make sure that it makes sense in the equation, so check for the extraneous solution. So we rewrite the expression, but we include the 4 in for m. So 2 times 4 minus 4 equals, and we're going to see if it's equal to the square root of 4. So the square root of 4 is just 2, and then 2 times 4 is 8. 8 minus 4 is 4. So does the square root of 4 equal to? It does. So this checks out, so it's not an extraneous solution. All right, now on to number 19. We need to get the square root all by itself. It looks like it already is by itself. There's no multiplying outside of the square root. There's no adding or subtracting outside the square root. So we just simply square both sides. So if I square this side, I get v squared. If I square this side, the square root just goes away and I get 2v. So now, some of you guys get confused on how to solve this. Here's how you solve it. Whenever you have a v squared or an x squared or anything squared, any variable squared, you need to zero out one side, okay? So I need to turn this into a 0. So the only way to do that is to subtract 2v from both sides. So I get v squared minus 2v is equal to 0. Then I need to factor it or use quadratic formula to find my two solutions. Yes, there's going to be two solutions here. So I have a v and another v, so I can factor those out, and I get v times parentheses v minus 2. And then for each one of these little factors, I set it equal to 0 and get one solution each. So from this one I get v equals 0, from this one I get v equals 2. So these are my answers. Now I'm going to check just to see if I have any extraneous solutions. So my first step is to plug in 0 to the equation. So if I plug in 0 for v, I get 0 is equal to the square root of 2 times 0. I need to see if these are the same. So 0 is equal to the square root of 2 times 0 is 0, and the square root of 0 is 0, so this checks out. Now try 2. So if I plug 2 in its place, 2 is equal to the square root of 2 times 2. 2 times 2 is 4, so that means that we need to test and see if 2 is equal to the square root of 4. Since it is, then that one checks out too. So neither of those are extraneous solutions either. On number 20, again, the radical is all by itself, so we just simply square both sides. The radical goes away, so we have 20 minus 8r is equal to r squared. Since we have a variable squared, we need to zero out one side. So I'm going to get rid of all this stuff over here. I'm going to add 8r to both sides, and I'm going to subtract 20 from both sides. So I get 0 on this side is equal to r squared plus 8r minus 20. Then I try to factor it. So numbers that multiply together to be negative 20, add together to be 8. That's going to be plus 10 and minus 2. And then I just solve each factor for r. So if r plus 10 equals 0, that means r equals negative 10. If r minus 2 equals 0, that means that r is equal to 2. So these are my two potential answers. Now I'm going to go ahead and plug them in and make sure that they're not extraneous. So if I plug in negative 10, I get the square root of 20 minus 8 times negative 10. And then is that equal to negative 10? All right, so let's see here. I actually already know that this is not going to be a viable solution, simply because a square root cannot be equal to a negative number. So I already know that this is extraneous, so negative 10 is extraneous. If you plug in 2, the square root of 20 minus 8 times 2, and we have to see if that's equal to 2. So 20 minus 16 is 4, so we get square root of 4, and sure enough, that is equal to 2, so that one works out. So one extraneous solution, negative 10, and then just keep going. Okay, so these next two problems, and all these problems, by the way, can be found in 4.3. So if you need some more examples, just go to the worksheet with 4.3, and you can just keep working through more of those. The radical is all by itself, so we square both sides. And here's where we want to run into some problems sometimes. And that's this, with the n plus 2 squared. You have to remember something. This is not just n squared and 2 squared. It's n plus 2 times n plus 2. It's the whole thing squared, so we need to FOIL that part of it out. This one's nice because the square roots just go away, so we just have 2n plus 3. But you got to remember to FOIL these ones out. It's going to be the same thing over here. We're going to be FOILing this one, okay? So just, look forward to that one. So FOILing this out, n times n is n squared. And then we have another 2n and another 2n on that. And then 2 times 2 is 4. Then we combine like terms, so we get n squared plus 4n plus 4 is equal to 2n plus 3. And again, we have an n squared, so we need to get 0 on one side. So I'm going to subtract away 2n and 3 on both sides, and I get n squared, and then 4n minus 2n is going to be 2n. And then 4 minus 3 is 1, equals 0. And this factors also. Numbers that multiply together to be 1, add together to be 2. That's going to be 1 and 1 again. So that means that both of these give me the same solution. That's negative 1. Now I'm going to go back and verify that negative 1 will give me a correct answer, and it's not extraneous. So if I plug in negative 1 plus 2, and I need to see if that's equal to the square root of 2 times negative 1 plus 3. So 2 minus 1 is 1, and then square root of 3 minus 2 is 1. And is the square root of 1 equal to 1? Yep, it is. So this one works out. Gosh, sorry. All right, so we already have the square root isolated, so we square this side and this side. If we square the square root, we get 24 minus 5n. And then if we square this, remember that that's the same as saying n minus 6 times n minus 6. So we have to FOIL it. So n times n is n squared. N times negative 6 is negative 6n. Negative 6 times n is negative 6n. Negative 6 times negative 6 is positive 36. So we get 24 minus 5n. Combining like terms, we get negative 12n plus 36. And then 0 out one side, so we're going to subtract 24 and add 5n. So on this side, we get 0, and that's equal to n squared. And then negative 12n plus 5n is going to be a negative 7n. 36 minus 24 is going to be 12. The numbers that multiply together to be 12 and add together to be negative 7 are negative 3 and negative 4. That's just, the x method, factoring. And then we get our two solutions. N is equal to 3 and also n is equal to 4. Let's see if we have any extraneous solutions. So we go back over here and plug both these numbers in, and something kind of weird happens. So watch this. So we get square root of 24 minus 5 times 3, and then see if that's equal to 3 minus 6. Well, 3 minus 6 is negative 3, and can a square root equal a negative? Nope. So this is going to be extraneous. Now let's try 4. Square root of 24 minus 5 times 4 equals 4 minus 6. 4 minus 6 is negative 2. Is the square root ever going to be equal to negative 2? No, it's not. So this is also extraneous. So for this one, we actually have no solutions. Pretty crazy, huh? Just make sure you check for those extraneous solutions. It's, easy couple steps, easy points really. Just, plug them back in. So that's it for this section. Just make sure to check out 4.3 if you need a little bit more help. Next, we're going to do domain and range and graphing, which is actually really easy for this chapter. All right, till then.